The NEET 2017 question in oscillations. Problem says like this. A spring of force constant K is cut into lengths in the ratio of 1:2:3, and then they are connected in series. So before talking about their series connection, what happens is let length of that spring equal to L. Now it is divided into three parts with ratio 1:2:3. That means L1 is in the total length. If there are 1 plus 2 plus 3, that is 3 plus 3, 6 parts are there. One part is there in the first spring. So L by 6. L2 is 2 parts are there in the total length, right? So out of 1 plus 2 plus 3, that is 6 parts, 2 parts out of 6 parts are there in L2. And L3 is 3 parts, it's the longest spring. Out of 6 parts, 3 parts are there in the third spring. So the ratio is L1 is to L2 is to L3 is L by 6 is to 2L by 6 is to 3L by 6. So all L's can be cancelled. Then this will be in the ratio of, so it will be in the ratio of 1 by 6 is to 1 by 3 is to 1 by 2, because 2 3s are 6 and 3 2s are 6. That is L1 is to L2 is to L3. Respect to spring constant is when K is inversely proportional to L, implies K1 will become 6K, K2 becomes 3K, K3 becomes 2K. As K is inversely proportional to length, spring with less length will have highest spring constant, spring with high length will have lowest spring constant. That's the first part of the problem. Look at the next part of the problem. When they are connected in series, their new force constant is, spring constant is K dash. So what happens when springs are connected in series? When springs are connected in series, the force is same, the elongation is shared. Basing on that, we have derived this 1 by K series equal to 1 by K1 plus 1 by K2 plus 1 by K3. That is equal to 1 by 6K plus 1 by 3K plus 1 by 2K. 6K is the LCM. 1 plus 2 plus 3. 6 by 6K, that equal to 1 by K. That's 1 by K series. So K series equal to K. Then what he said further is, if these springs are connected in parallel, their new spring constant is K double dash. Let's talk about that part. When these springs are connected in parallel, I know in parallel force is same and force is distributed and elongation is same. K parallel, we have derived these derivations in oscillations playlist. Please go through them to get that. How do we get this derivation? K1 plus K2 plus K3. K1 is 6K, K2 is 3K, K3 is 2K. That is 11K. That is K parallel. Now he want K dash, that is K series, is to K double dash, that is K parallel. K series is K, K parallel is 11K. K and K will cancel. So the ratio is 1:11. That's the answer for the problem. So it's a very simple problem, very conceptual problem. and you know a lot of basics while you are solving the problem. That first thing is, how do you write the length for each part? If the total is divided into 3 parts with lengths 1:2:3, out of 1 plus 2 plus 3, 6 parts, 1 part is there in the first spring, 2 parts are there in the second spring, 3 parts are there in the third spring. That's one important lesson. Next, spring constant is inversely proportional to length. Next, springs in series, we have a formula. Springs in parallel, effective spring constant, we have a formula. Let's learn all these things while we are learning this question so that they will be helpful while we are solving other problems. Thank you for watching.